Good morning everyone. Welcome to the second video. Oh, before that, I forgot to wish you all a happy new year and let this new year bring you all sorts of good results that you people are venturing into. And I wish you all, most of you who are looking into this video, pass are clear with great colors like the colors that you see here in your IBDP exam and as well as in your JE mains and advanced, or maybe whichever exam you are going to compete with. Okay, so now without wasting your time, let me just continue with this. Right. So let us look at the second video, the solution for the second video. I hope by today evening, because now I am recording this at an early morning time, so I might be uploading this one by evening. So let us see how does it work. Okay, so you may not be able to see it in time, but anyway. So towards it, the first question says, the diagram shows below the part of a downhill ski course. Okay, so there's an object. It starts at point A, 50 meters above the level ground. Point B is 20 meters above the level ground. A skier of mass 65 kg so starts from rest. So this statement says U equal to 0 at point A. So there's a person here who starts skiing over here. Gravitational potential energy is converted into kinetic energy as the person starts moving like this. Definitely the potential energy decreases, kinetic energy increases. From A to B, 24% of the GPE is transferred to kinetic. So when it comes over here, he says that 24% of the potential energy has got converted into kinetic energy, half mv squared. Okay. Now he is asking you to show that the velocity at B is 12 meters per second. So how do we do it? See, the statement itself very clear is this. So what I should do, 24%, which is nothing but 0. What is this? Okay, which is nothing but 0.24 multiplied by what is the potential energy? Potential energy of what? Potential energy transferred to kinetic energy. So it is nothing but mgh. Mgh should now be equal to half mv square. Half mv square, right? Just a moment. Some notifications are coming. Let me close this. Okay. Now, when I write about this h, which h should I talk with? Okay. This h is not equal to 50 meters here, but instead, the difference between these two. That's what you should write. So therefore, this should now be equal to 0.24 multiplied by this m, and this m gets cancelled over here. This is 10 multiplied by h. What is h? Is 30 over here, right? 30 should now be equal to half into v square. So let us solve this. There should be 2 into 0.24, 0.48 multiplied by 10 into 30. I'll write this as 300 is equal to v square. So now 3 8s are now what will do? What will I have it here? I don't have a calculator. I am just doing it manually. 100 into 0.4 is 48. 48 into 3. 3 8s are 24. 2 3 4s are 12. 144 should now be equal to v square. Or v should be equal to square root of 144, which should be equal to 12 meters per second. Right? So that is what is to be required, which means now it is showing that, okay, so this should be 12 meters per second. So we have proved this. Now let us move on to the next question. Some of the GPE transferred into the kinetic internal energy of the sky is slightly increasing the temperature. Distinguish between internal energy and temperature. So what is internal energy? What is temperature? So this is an application problem from your next chapter. That is on thermal physics. Anyway, let me just give an answer for this also. What is internal energy? Internal energy is nothing but the average kinetic energy of all molecules. This is your internal energy, which means what? If I take one molecule here, second molecule here, let this be moving with the velocity v1, this is velocity v2 and so on. Okay, so now what I do is I take half m1 v1 square plus half m2 v2 square and so on. And I keep on adding all this so that I get take the average of this. This will give me the internal energy. Just a moment. I am just joining. Okay. So average kinetic energy of all the molecules. Yeah, there is this cursor here. Just a moment. Right. So average kinetic energy of all the molecules, if you look at it, okay, so you will do something like this. So this is proportional to the temperature. Okay, this is proportional to temperature. So anyway, V1, V2, V3 can be negative or positive. So it is proportional to temperature. So as this average energy increases, temperature increases. This what is temperature? What is internal energy? Oh, I put this mark here. I'm sorry. I think I told you internal energy. It's the other words. Okay, so this is temperature. So this is a definition for temperature. What is internal energy? Internal energy is nothing but total kinetic energy of all the molecules. Total kinetic energy of all the molecules is what you call it as a the internal energy. This is called as internal energy. Okay, there's a difference between these two. Here it is average of all the kinetic energies, and here it is the total kinetic energy. Okay, next is the dot on the following diagram represents the square as it passes point B. Draw and label the vertical forces on the square. So when the square is at this point, why this point, where does this point arise? If you look at this point is nothing but the point B here, right? So he passes like this. He passes like this. So therefore, this is the point B here. Now, what forces are acting here? Now, still she is on the spot here itself. So therefore, there is a normal force acting here, and there's an mg force acting here. Okay, you can write like this. But now once again, okay, what if the surface, if it was given like this, then definitely, okay, you are right. This is my normal force. This is my mg force. But unfortunately, now she says, as she passes point B, the diagram is shown like this, like a circular arc here. Which means when a particle is moving in a circular arc, which other force should act? There will be one more force. What is that force? mv square by r. Okay, so this should also be mentioned because she is moving in the circular arc. So definitely that should be there. Then the hill at point B has a circular shape with a radius of 20 meters. Now it's already given. This is the center of the circle. This distance is equal to r, 20 meters. Determine whether the skier will lose the contact with the ground at point B. Whether the skier will lose the contact. So how do I understand? Now this is a question taken from circular motion. You see, you started with a question on the first chapter. Then we moved on to second chapter. Now this is your question on your sixth chapter. Okay, see how the questions have been linked. You have to be very careful in answering the IB papers. Now, the hill at point B has circular shape. So therefore, now let us write down the equation. So towards it, now the particle is going downwards. So I will just write mg minus n is equal to mv square divided by r. Okay, this is what I will do. Now towards it, what has been given here? It has been given. We already found out what's the velocity at this point. Velocity at point B was 12 meters, right? What is the mass? Mass, what is the mass of this sky here? What's the mass? What is the mass? What is the mass? Mass point B, 65 kg. 65 kg is the mass. Okay, so therefore this is 65 kg. 65 kg multiplied by 144 divided by 20 meter. 20 meter is equal to what is m? 65 into g value 10 minus n. I need to find out what's the value of n. If the value of n is greater than 0, then the particle is still on the mount. If the value of n is equal to 0, definitely, yes, she has escaped from it, or she is no more in contact with the mount over there. Okay, let us find out that. So this should now be equal to 650 minus n should now be equal to 65 into 144. Oh my God, where is my calculator? I should get my calculator. We have been addicted to this calculator here. Huh? Without calculator, you can't do anything. Just give me a moment. 65 into 144 divided by 20. I got it now. Let me just calculate this. I don't have the solution directly with me. 65 star 144 divided by 20. I didn't type anything. Okay, let me type it out. 65 star 140. Oh, wait just a minute. There's a 0 here. 65 into 144 divided by 20 is 468. So you get the answer here as 468, and then you have n should be equal to 650 minus 468, which is greater than 0. I am not interested in finding out what's the value of n, but anyway, it's for 3 marks. So I can find it out. What is this value? How much will this be? I missed my calculator here. 468 minus 650. See, 182. So the answer here is 182. What is the unit? Newton. So n is positive as a result of it. The point, the skier has not lost contact with the ground at point P. So I can now say not lost the contact at B. So what you need to do here is that how is the marks being distributed? 3 marks. The marks has been distributed, 1 mark for your FBD, the second mark for arriving at the answer, and finally your conclusion. 3 marks. You should write it neatly. Okay. So if you just write, okay, just you this one and get the value of it, and then you do not mention anything here, you won't get full marks either. Okay, you have to be careful. Right. The skier reaches the point C with a speed of 8.2 meters per second. Where is the point C? Let me go back. Point C is at this point. Which is this point? Horizontal. Okay. Point C at 8.2 meters per second. She stops after a distance of 24 meters at point D. Okay, so you get like this. You get like this. And then this is point C and this is your point D. This is your point C and this is your point D. So she stops at point D. Why should she stop? The reason is because when she comes here, her velocity was 8.2 meters per second. But when she comes here, the velocity is 0. Why? Because something is pulling her back. What is pulling her back? The frictional force, right? Frictional force. What is this distance? Distance is given to you as 24 meters. Now what is being asked? Determine the coefficient of dynamic friction. What is the friction value of mu here? Okay, between the base of the skies and the snow. Okay, what is this? Between, assuming that frictional force is constant and air resistance can be neglected. We need to find out. Now, what is the formula for friction? We know that, just a moment, let me pull this back here. Okay, now we know that frictional force is given by mu times m. When will it be mu times m? When the object is sliding, when the object is moving, right? Not rolling, okay, only in sliding. So therefore, what is frictional force here? Has it been given? Frictional force is given over here. What is being asked? Dynamic coefficient of dynamic friction. Okay. Now he says the sky reaches the point C with 8.2 meters per second. So this is your initial velocity. Your final velocity is equal to 0. So you need to find out the acceleration first. Acceleration A, let me write down here. Acceleration A is equal to V minus U divided by T. Can you use this? No, T is not given, so you cannot use this. Okay, this is outdated. Now, which equation can I use? I can use V square equal to U square plus 2AS. Now you have U. U is already there, 8.2. V is 0. 0 is equal to 8.2 square plus 2 into what is A? A, what is A? What is A? What is A? A is not known. Oh, VA is what we need to find. Okay, multiplied by S. What is S? 24 meters. 24. This we know. So which means you can get the value of acceleration here. A should now be equal to minus 8.2 square. I urge you people to work it out. Don't copy from my result. If you copy from my result, it'll be very difficult. I just skip steps sometimes. Okay, to see to it that you work it out. And don't say, sir, I do not know how do I get this. Do work it out. Okay, now without wasting our time, let us find out what is the value of this 8.2 square. Okay, so 8.2 star 8.2. I am using my calculator in my laptop divided by 48. You can use your GDC and I get the answer as 1.4. 1.4. So this is minus 1.4 meter per second square because acceleration. Now we already know this frictional force is equal to mu times n, or this should be equal to mu times mg over here. And we also know that this frictional force can be written as m times a, Newton's second law. So this m and this m goes away. I get a equal to minus mu times g. Now what is required? We are doing many things over here. Now we already got the value of a, which is minus 1.4 is equal to minus mu times. What is the value of g? 10. Let me substitute 10 here. Okay, so this negative and this negative goes away. So therefore, what is this here? A which I have calculated here. I've taken it here. And thus your value of mu is equal to 0.14. Right? The value of mu equal to 0.14. So the answer here, what has been asked? Coefficient of dynamic friction. So this value is mu is equal to 0.14. Right. Then calculate the impulse required from the net to stop the skier and state an appropriate unit for your answer. You need to find the impulse. What is impulse? Impulse is nothing but force multiplied by time. A force acts, okay, for a short interval of time. That's what is impulse. At the side of the course flexible, then safety nets are used. Another skier of mass 76 kg. Now, when I write something like this, from your Newton second law, this is nothing but your momentum, change in the momentum. Okay, so F into delta T is equal to delta P, or F equal to delta P by delta T, Newton's second law, right? So therefore, now he's asking you to either find it using this method or this method. Now, another skier of mass 76 kg, mass is given to you. Normally, it travels into safety net with a speed of 9.6 meter per second. Now, what velocity is this? Initial velocity is given to you. Now, when he falls onto the net, what will happen? When he falls onto the net, the velocity becomes 0, right? Because it supports him. Suppose by accidentally he falls onto it. That's what it happens. Normally into safety net. So therefore, what is delta P? Delta P is nothing but M into V minus U, right? So therefore, now what is he asking? Impulse. So let us substitute the values. What is M? M is nothing but 76 kgs multiplied by V, which is 0, 0 minus, what is U? U is 9.6, right? So let us find out what is this value now. This value should be 76 star 9.6, which should be 729.6. 729.6. 729.6. What is the unit? It's Newton second. See, this is Newton, this is second over here. Okay, state an appropriate unit for your answer. You can put Newton second, or if you want to use SI units, you can use that also. Nothing wrong. Everything is right. Okay. Now, one more thing is that, see, when you use 9.6 here, 76 here, there are two significant figures. So here there are four significant figures. So what you should do, your final answer should be 730 Newton second, or your answer should be 730. What is Newton? Newton is kg meter per second square into second, which should now be equal to 730 kg meter per second. Okay, you can write like this also. Both the answers are correct. Until and unless if the question asks on what is the unit or mention the unit in fundamental SI units. Mention the answer in fundamental SI units, you have to write this one. If he says state an appropriate unit, you can always convey using this method. Okay, I hope you got this. Now let us move on to the next one. But take care of the significant figures, very important. Explain with reference to change in momentum why a flexible net is less likely to harm the skier than a rigid barrier. Why do we need this? Oh, the answer to this is, okay, when you have a flexible net, so what happens here? See, for the impulse to slow down, it will definitely take some time, right? So how much time will it take? Let us say, for example, when the person lands onto a flexible net, let him take something like, let us say, 2 seconds. If it takes 2 seconds for him to stop, then what will be the force? Force will now be delta P divided by delta T. Delta T. I'll write it here. F is equal to delta P divided by delta T, which should be delta P is what? 730, which we have already got. 730. Let us say it takes only 2 seconds. Usually it doesn't take 2 seconds. More than 5 seconds it takes. Okay, to land onto it, then it will sag like anything, and finally it'll come back to it. Okay, so if it takes only 2 seconds, let me take this a very stiff net. Okay, not a flexible one. At the worst part, if I take 2 seconds over here, then how much will this answer be? This will be 2 3s are 6, 2 6 are 12, 365 newtons I get. Okay, 365 Newton is equal to, I'll write this as 36.5 multiplied by 10. Okay, what is 10? Why should I put 10? Okay, this I'll explain. Okay, so if I write this 10, can I write this equal to something like 36.5 G? This is equal to some M into G, which means that your whole object, okay, as a mass, if you have 65 kgs, you go and crash onto the flexible net, then your weight, you will feel a force as if a 36 kg weight is now being hit on you, okay, with for a very less interval of time, only for 2 seconds. So here, can't you even bear a 35 kg weight for 2 seconds? Definitely we can bear, but usually it doesn't happen so much. This is the worst case I have put across. Now the real case, what happens is it takes at least 5 seconds. If it takes 5 seconds, then what can happen?
you will have 730. Let us do the same calculation once again. 730 divided by 5 when I do this. So how much do I get? 5 ones are 5, 23 remaining, 5 fours are 20, and then what is that? I am 5 fours are 20, sorry, 5 ones are 5, 13, 5 twos are 10, the 30, 126 Newton, which is equal to 12.6 Newton. It's how much? It's nothing but, so 12.6 G, 12.6 G, which means what? A 12 kg object hitting on your body, okay, for only for 5 seconds. Can't you bear it? You can definitely bear it, right? You won't experience that much amount of what you call the damage. Okay, that's why a flexible safety net is used. So what is the answer? So we have, either you can give it in the form of the answers like this, or you can also say the flexible safety net is used to increase the time of impact. Time of impact, right? You need to increase the time of impact. That's the reason why even in cricket balls also, the moment you catch it, what you do? You catch the ball, which is coming at something like 100 kilometers per hour. You don't just catch it like this. You just pull your hand backwards. Which means what? The impact that falls on your hand has been reduced. You pull it for at least 2 seconds. So impact now starts reducing. So while you reduce it, do you do it like this slowly? No. You move it with the same speed as it comes down, and then slowly you bring it to rest, right? So that's what happens. Okay, so now let me move on to the next question. A glider is an aircraft with no engine. I hope you have seen this. To be launched, a glider is uniformly accelerated to rest by a cable. So you will have an engine here, a cable here, pulled by a motor. There will be a motor here, there will be a motor here. You will pull this. There's no engine here. Okay, so you only by use of the Bernoulli's theorem over here to have a lift that exerts a horizontal force on the glider throughout the launch. Okay, the glider reaches its launch speed of 27 meters per second after accelerating for 11 seconds, which means what? The glider initially was at rest. It reaches a launch speed of 27 meters per second. V is 27 meters per second. See, when we read the problem itself, you have to write down what all parameters are given. After accelerating, you do not know the acceleration for t equal to 11 seconds. That's being given. Okay. Assuming that. Now from here, you can easily find out the value of A. But let us see what has been asked. Assuming that the glider moves horizontally until it reaches the ground. Okay, it moves horizontally. What is the distance traveled by the glider before it leaves the ground? So how do you solve this? Simple. Okay, see, acceleration is constant. So use the equation S equal to U plus V divided by 2 multiplied by T. Right? So you can use this. Of course, some of you can think that why don't I use S equal to UT plus half AT squared? But the value of A is not known. Then you have to submit and then get the answer. Substitute for A and then get the answer. So I have taken the fourth equation of motion. You can do it by that method also. You can try it out. Okay, so this should be equal to 0 plus 27 divided by 2 multiplied by 11, which should now be equal to 2 ones are 2, 13.5 multiplied by 11. Kitna hai bhai? 13.5 multiplied by 11 is equal to how much? 13.5 star 11 is 148.5. 148.5 unit meters. Okay, now you see two significant figures. So what I should do? This answer should be 150 meters. Okay, in bracket write it as 2SF. Okay, so answer is 150 SF here. 150 meters. Right. The glider and the pilot have a total mass of 492 kg. So this mass is equal to 492 kg. During the acceleration, the glider is subject to an average resistive force of 160 Newton. 160 Newton. Okay. Determine the average tension in the cable as the glider accelerates. Okay. Now, for this, what you need to do is, now this is the cable. So you have, this is the cable. This is the glider. I am writing the glider in the form of a box. And then I'm putting this on the ground. Now, where is the resistive force acting? This is my tension. Something is pulling. This is my tension. Where is the resistive force? The resistive force is acting like this. How much is it? 160 Newton. 160 Newton. Then mass of it is 492 given. Now let us draw the FBD. What is remaining here? This is my mg. This is my normal force over here. Now what is that I need? I need the average tension in the cable as the glider accelerates. Now as the glider accelerates, which means what? So this is now accelerating like this. Now if I write the force equations, what do I get here? I will say T minus 160 Newton should now be equal to M into A. Am I right? 160 is acting in this direction. T is acting in this direction. This direction is taken positive. T minus 160 should be equal to net force. It is M into A. What is M? M value is 492. 492 into A. Array, once again, we don't have the value of A. So what I need to do is get the value of A. See, here we escaped. Now you cannot escape. You need to get the value of A. So value of A is nothing but V minus U divided by T. Let us substitute that value. What is V? V is nothing but 27 minus U 0 divided by time. What is time? 11. So what is the answer for it now? Let us substitute that value. So this should be 27 divided by 11 is 2.45454545. Oh my God, kitna 45 hai? 2.46 unit meter per second square. This is not the answer for it. I don't have space, so I'm writing it here. So T should now be T minus 160 is equal to 492 into 2.46. So when I substitute this value, how much do I get? This star 492 is 1,207. 1,207. I get this. Yes. Okay. Our T should now be equal to 1,207 plus 160 should now be, once again, calculator Baba, plus 160 is 1,367. 1,367. My charger is gone. I think now it was done. Okay. So it should be 1,367 Newton. 1,367 Newton. So finally we have 1,367 Newton. So now you see this is 160, this is 490, 1,367. How do I put it? If I put it as 1,400, now this has two significant figures, this is three significant figures, it's fine. Okay, because 1,400 would be too much an approximation. Okay, so I can just keep it as 1,370 Newton. That is here 3, here it is 2. I can keep it as 1,370. But strictly speaking, you have to keep it in 1,400. But your marking scheme says, okay, even if you do not mention it in three significant figures, two significant figures, it's well and fine. Okay, so fine. Let us move on to the next one. Then, or maybe while in the exam, what you have to do is you have to keep it in 1,400 here and write it down. First, you write down this answer. Then you write down 1,370 for 3. Write it as 3SF, okay, or 1,400 as 2SF, okay, which means the examiner gets an idea that you are aware of what is significant figures. Let us move on to the next one. The cable is pulled by an electric motor. The motor has an overall efficiency of 23%. Determine the average power input to the motor. So it's pulled by an electric motor. Okay, motor has an overall efficiency of 0.23, 23% is there. Determine the average power input. Now, how do we do this? Now, what is being given? Tension is given. Okay, what is the velocity? 27. So, what we do is, so force multiplied by velocity is nothing but power, right? So, therefore, this should now be equal to, what was the value you got? 1,367 or 1,370 multiplied by 27. 1,370 multiplied by 27. What is this now? This is your watts. This is what I got. Now, which power is this? Okay. So is this an input power or is it an output power? This is your output power over here. Okay. Now input power. Now because it's been pulled by an electric motor, right? So you need to find out what is your input power. So let me write P output by P input is equal to 0.23, which means what is that I need? I need P input. P input should now be equal to P output 0.23, which should now be 1,370 multiplied by 27 divided by 0.23. Let us do that so that you get a correct answer. 1,370 star 27 divided by 0.23. It is 160,826. Bigger number. Okay, 160,826. 826 watts, which should now be, how much it is? How do I put it? Now I put it in kilowatts. I'll write this as 160 kilowatts. Right? I get it 160 kilowatts. Just a moment, somebody is at the door. I'll just open, come back. Okay. Back. Okay. After takeoff, the cable is released in the unpowered glider. Okay. Unpowered glider moves horizontally at constant speed. Constant speed over here. The wings of the glider provides a lift force. It provides a lift force. The diagram shows a lift force acting on the glider, and the direction of the motion of the glider. Draw the forces acting on the glider to complete the free body. Okay, you need to fulfill the free body diagram. So when the glider was moving like this, it was a resistive force. Okay, so this is your drag, and then you had when the after takeoff, the cable is released in the unpowered glider, moves horizontally at constant speed. The wings of the glider provides a lift force. The diagram shows the lift force acting on the glider in direction of motion. So it has not been, it has been after takeoff. After takeoff. Okay. So while it is in air, when it is in air, there's an mg force here. Mg force over here. There's an F drag over here and nothing else. They don't have a normal force. Remember, do not put a normal force over here. If you put a normal force, what will happen? Okay, normal force means the object is still in ground. But look at this, it says, okay, the glider moves horizontally at constant speed after takeoff the cable. Okay, and hence you will not have, yes, you will not have anything like your normal force. Okay. Just a moment. Yes, you don't have a normal force. Okay. Then I usually work out everything before I do it. Right. Now the last problem. A girl on a sledge is moving down on a slope at a uniform speed. Okay. Draw the free body diagram for the sledge at the position of shown on this snow slope. What is a free body diagram? Simple. There's a normal force acting here. There's an mg force acting downwards. And if this angle is theta, then you can write this as mg cos theta. This is your mg sine theta. And it says uniform speed, which means there should be a frictional force. Okay, so this is what is important here. Many people do not write this. You have to mention it because uniform speed. If there was no friction, this would have been accelerated onwards because this would be the only force acting. Okay, now we have done this part. Then after leaving the snow slope, the girl on the sledge moves over a horizontal region of the snow. Okay, now she's here. Right. Explain with reference to the physical origin of the forces, why the vertical forces on the girl must be in equilibrium as she moves over the horizontal region. Now, when the girl is here, why the vertical forces on the girl should be in equilibrium? So what are the forces acting here? One is a normal force. The other one is an mg force. Okay. So now first thing is 1 mark goes for your FBD here. Okay, so you have to mention the two forces that acts on the girl when she is in the horizontal region is the normal and the mg force, exactly opposite. Then if normal force was greater than mg, then she would have jumped upwards, or maybe she would have been flying in the air, right? So that's what you have to mention. And usually normal force cannot become greater than mg, okay, because normal force can become 0. It cannot be greater than mg. Then if mg was greater than normal force, then she would have sunk into it. But what is being given over here? It says that she is in equilibrium as she moves over the horizontal region, which means there's no depression. It is just going over like this. It's going at the same pace, and as a result of this, okay, so the normal and the mg force should be balanced so that neither she goes inside the ice or inside the snow, or she's been lifted upwards or flying upwards over there. Okay, now let us move on to the next question. When the sledge is moving on the horizontal region of the snow, the girl jumps off the sledge. Okay, she wants to jump off. The girl has no horizontal velocity after jump. Okay, the velocity of the sledge immediately after the girl jumps off is 4.2 meters per second. The sledge, now you have, this is my sledge, and this is the girl who jumped off from here. The mass of the girl is 55 kgs. Mass of the girl is 55 kgs. And the mass of the sledge is 5.5 kgs. Mass of the sledge is 5.5 kgs. Okay, calculate the speed of the sledge immediately before the girl jumps from it. Speed of the sledge immediately before the girl jumps from it. So initially the girl is on the sledge, and then the velocity of the sledge immediately after the girl jumps. V sledge. Now, it is nothing but your internal explosion problem, conservation of momentum problem. So what is happening? So you have two particles. You have studied this in your explosions also, right? You have a bomb, for example. Suddenly, okay, this gets broken like this. It explodes. It goes in this direction. This goes in this direction. And then you apply your conservation of momentum, right? The same thing is happening here. But there it was an internal force. Now, the velocity of the sledge, the girl has no horizontal velocity after jump. The velocity of the sledge immediately after the girl jumps off. When the sledge is moving, immediately after the girl jumps off is 4.2 meters per second. Velocity of the sledge. Okay, so let us write before jumping, after jumping. Two parts. Immediately after jumping, so V sledge is equal to 4.2. 4.2 and V girl is equal to 0. Then the mass of the girl is 55 kgs. Mass of this one. Calculate the speed of the sledge immediately before the girl jumps from it. What was the speed of the sledge? Okay, when the girl was jumping. Now, before jumping, the girl and the sledge were together, which means they were stuck together. Okay, which means the total mass here is nothing but 55 plus 5.5, which is equal to 60.5 kgs. This was the total mass of it. Okay, and this was a Vs. We do not know this one. Now let us apply your COM. What does your conservation of momentum tells you? Which tells you momentum before jumping, which is m times Vs, is equal to momentum after jumping. What is momentum after jumping? Momentum after jumping is nothing but m sledge V sledge plus m girl V girl. V girl is 0. So therefore, now this is 60.5 multiplied by Vs. We do not know what is Vs. Ms, what is 55 multiplied by Vs? What is V sledge? This is after, which is 4.2. 4.2. So Vs here, let me call this Vs dash. Vs dash should now be equal to 55 into 4.2 divided by 60.5. Okay. So thus, let us calculate what is this value. This value would be, where's my calculator? 55 star 4.2 divided by 60.5. So I get this as 3.81. 3.818 or 3.82 unit meter per second. Okay, thus the answer here, the speed of the sledge immediately before the girl jumps from it is 3.82 meter per second. The moment the girl jumps outside, then what happens? There's an equal and opposite force acts on the sledge, and the sledge just starts moving faster, right? You would have observed it. For example, I'm sitting on this chair. Now the chair and me are constantly standing there, sitting there. Now the moment I leave the chair like this, what happens was the chair moves backwards, but with the speed. Initially it was sitting, but when I got up, the chair moves backwards. Okay, because I applied a force on it. Okay, so the same example is given over here. The girl chooses to jump so that she lands on loosely packed snow rather than frozen ice. Choose why she chooses to land on the snow. This example, this question is very similar to the previous question, which had safety nets. So loosely packed snow is something like your safety net as compared to frozen ice. Frozen ice is much more thicker, right? You cannot compress it. But loosely packed snow, it's easily to compress. So that's why we throw the snow one upon another, right? Okay, so as a result of it, so what can you say? The impact of jumping is not felt when we jump on a loosely packed snow. Loosely packed snow. Okay, let me move on to the next one. The sledge without the girl on it now travels a snow slope that makes an angle of 6.5 degrees to the horizontal. Now the sledge is moving like this. Sledge is moving like this. And then it is moving like this. And as it moves, it travels on a slope like this. On a slope like this. At 6.5 degrees to the horizontal. 6.5 degrees. At the start of the slope, the speed of the sledge is 4.2 meters per second. So at this point, it is 4.2 meters per second. The coefficient of dynamic friction on the sledge on the snow is 0.11. So here it is 0.11. Show that the acceleration of the sledge is about -2. Now how do we show this? So 4.2 meters per second. Here there is no friction at all. The moment it comes here, there is a friction. Okay, so what should we do? When the particle is on the sledge, we have to show this. Now let us use total work done. Okay, so what is the energy here? The energy of the sledge is half mv square, where v is equal to 4.2. Now as it keeps on moving, now what does it say at the start? Now traverses makes an angle of 6.5 degrees, and as it keeps on moving, now what happens to this energy? The energy, no, you cannot use this because we do not know what height it goes. Okay, let us not use this one here. So what we do is it comes over here at 4.2, it keeps on climbing upwards. Let us draw the free body diagram. This is my normal force. This is my mg cos theta, and this is my mg sin theta, and this is my frictional force. Sorry, this is my frictional force, opposite direction. Okay, so therefore, now the net force is nothing but mg sin theta plus frictional force is nothing but the net force. Just a minute, somebody is at the door. You just come. Okay, so therefore, yeah, okay, mg sin theta plus frictional force is equal to F net. And this is negative over here. Why negative? Because this is going in the opposite direction, but the object is moving in the forward direction. Okay, so therefore, now what I will do is let me substitute all the values. This should be minus mg sin theta, minus of mg sin theta plus mu times n is equal to m into a. Okay, now what is n? N is nothing but n, if you observe here, n is nothing but mg cos theta. Okay, let us substitute that. So minus of mg sin theta plus mu times mg cos theta should be equal to ma. Now I'll cancel this m and m over here. I'll get minus g into sin theta plus mu cos theta is equal to a. What is that I want? I want the value of a. Very easy, no? So I'll write a should now be equal to, what is g? Minus 10 into sin theta. I'll substitute sin of 6.5 plus mu. What is mu? 0.11. 0.11 into cos of 6.5. Okay, let me calculate this value. What is sin of 6.5? Sin, there is sin here. When I do this, I get the answer as, I've already done this. Okay. So when I do this, I get this answer as minus 10 multiplied by 0.622 plus 0.601. Okay, this whole thing. And this should now be equal to, 0.622 plus 0.621 multiplied by 10. I'll keep it just like this. And then I made something wrong here. Okay, it's correct. Okay, sorry. You just do these calculations. Okay, when you do this value, substitute the values over here, you get the value of A to be equal to minus 2.2 meter per second square. Okay, use your calculators to get this value, and thus you get minus 2.2 meter per second square, and which is roughly equal to minus 2 meter per second square. Calculate the distance along the slope at which the sledge stops moving, assuming that the coefficient of dynamic friction is constant. Next one. So as the sledge stops, because there's a friction here, right? So therefore, when does it stop? Very simple. Or where does it stop? That's the question here. What is the distance moved by it along the plane? So what do you do here? So what you do is use your v square is equal to u square plus 2as. What is v? Stopping. 0. What is u? U. It's already given here. 4.2. 4.2 square plus 2 into, what is a? Minus 2, which is already given, into s. Right? Now determine value of s. S should be equal to 4.2 square divided by 4. Okay, so what is the value over there? 4.2 into 4.2 divided by 4 is 4.41. So answer is 4.4 meters, right? Okay, now let me move on to the next question. The coefficient of static friction between the sledge and the snow is 0.14. What was the earlier value? 0.11. Now you are increasing to 0.14. Outline with a calculation, 2 marks. Okay, the subsequent motion of the sledge. Okay, what will happen to the sledge? So towards it, now what we need to do is, what was the friction? Frictional force is equal to mu times n, right? And what did we do here? So this should now be equal to mu. What is 0.14 into mg cos 65, 6.5. Okay, which should be 0.14 into what is mass? Mass is 5.5 kg multiplied by 10 into cos of what is 6.5? Cos of 6.5. I need the value of cos of 6.5. Otherwise, we will not be able to calculate this. My calculator doesn't support it. That's the problem. Anyway, let me try it out. Trigonometry cos of, okay. I have to first write this. Then I will put cos of 6.5 is 0.99. Okay. So I'll write this as 0.14 into 55, 5.5 into 10 into 0.99. Okay. When I do this, I get star 55 star 0.14. What is this? 7.65. So the frictional force acting on it is seen to be 7.65 Newton the moment the sledge starts climbing here. Okay. Now let us find out what is the force given to it here at this point. The force given to it is this point is 5.5 multiplied by 2. Okay. So which should be equal to 11 Newton. Sorry, something is wrong. Net force acting on it. Net force acting on it should now be, so I am getting the 7.65 Newton. And sorry, when it starts climbing here, the pulling force downwards, what has happened to this? The pulling force downwards is nothing but mg sine 6.5, not this value. Okay, so mg sine 6.5. What is m? 5.5 multiplied by 10 multiplied by sine 6.5. Once again, calculator. So 6.5, and I want the value of sine. Sine 6.5, 0.11. 0.11, which should now be equal to 5.5. 5.5 star 10 star 0.11 is equal to 6.05. 6.05 Newton. See, this force is just 6.05 Newton, but the frictional force is now much more larger than this. As a result of this, the object, so this is 6.05. Now, if I add to here, 6.05, when I add this, 5 plus 5 is 7, 13. 13.7 Newton is the total force acting on the object. But the upward force, m into a, is just 11 Newton. 11 Newton. So when the pulling force is larger than the pushing force, the object doesn't have the ability to climb up. As a result of it, the object will not go upwards. Okay. So you have to write the whole calculation and you need to mention the object will not climb the incline. But I have climbed, see. Okay, so fine, we have come to the end of the question. So thank you friends for watching this video with great patience until now. And if you really like this video, do share it with your friends and do subscribe to my channel to get more updates like this and be glued in. Thank you once again.